So what's a communication system? Yeah, you're going to have voice or data, which in this case, like what I'm talking over here, it goes to my PC through the microphone. The PC is essentially processing it and converting it. The transmitter in the PC is a Wi-Fi transmitter that is transmitting it at 2.4 gigahertz, and that goes to my let's say my router or some other Wi-Fi device. This Wi-Fi device is going to receive it at 2.4 gigahertz. When this is transmitting at 2.4, you have to receive at 2.4. You can't be receiving at some other signal, yeah? At some other frequency. That means you're not completely tuned. Yeah, you need to match and tune to the transmit frequency so that you are able to receive that signal, goes into the receiver, and you can reconstruct back what has been transmitted. As simple as that. So the transmitter has what is called as a modulator or an up converter. Turns out that this voice signal is a low frequency signal that you can't transmit right away. Electromagnetic energy takes propagation to happen. You need what are called as antennas, which become good radiators only when the frequency is beyond a certain level, because these antennas become dependent. Their size is dependent on the frequency of operation. More importantly, on the wavelength of operation. Wavelength is very low, then the antennas are very small. If the wavelength is very high, then the antennas are very big. So if you go to the Bukitima Hill, you will see very large antenna posts over there, right? Those are transmitting your AM broadcasts, AM audio broadcast, or your FM broadcast. Those are very low frequency signal. The wavelength is high, so the antennas are huge. But you can't be carrying such an antenna on your mobile phone, isn't it? So that's why to use an antenna in the form factor of your mobile phone, you are bound by the physics to be able to push the frequency higher so that the wavelength gets lower, and hence the size of the antenna required is also getting lower, right? So how do you convert this signal to that high frequency signal? That process is called as modulation. The process is called modulation. And when you transmit it, turns out that you have to convert back that high frequency back to the low frequency here. So that is called as demodulation. So you need to shift it back. But the important catch here is when you transmit something, when you receive something, the power in what you receive is not exactly what you transmit, because there's something called as a path loss, which we'll be seeing later on. Yeah. So there are some losses as the signal propagates through, and when it reaches the receiver, it's going to be very weak. So when you have a weak signal, the first thing you want to do is amplify it, yeah, so that you don't lose out the information that has been sent across. So when you amplify the signal, you're going to have what is called as a power amplifier. That is what you're going to be using even in a transmitter. For example, this case is a transmitter. Whatever signal that you have, it's not sufficient to cover the range. Suppose you're 10 kilometers away, I need to boost it up to a very high signal strength. Then what I have to do is use a power amplifier. Just like if you're not able to listen to me right now because my voice is feeble, then I have to spend more energy to talk louder, isn't it? So similar to that, it's going to be that you need to boost up and have an amplifier there. And when this guy gets transmitted, when you receive it, it's going to be a very weak signal because it has gone through free space and it's going to have so much losses into it. So the first thing you would want to do is, as you receive from the antenna, you're going to amplify it. And it's a special amplifier called as a low noise amplifier, where the signal gets amplified. Yeah, the signal gets amplified in the process of not and adding noise unnecessarily in. Yeah, so such is a low noise amplifier. And eventually you want to have a down converter or demodulator to recover your signal back. The original signal gets recovered back. So how good are you able to get from the transmitter to the receiver? That's the fidelity of the system. How clean the communication system chain is. So this is a TX and this is an RX, right? But then what if this guy wants to listen and this guy wants to talk? So it's not like simply a one-way communication, right? So that becomes like, then in my system, I don't have just my mouth, but I need my ears, isn't it? I use my mouth to speak and ears to listen. So my brain has this so-called transceiver architecture, similar to yours, right? You're able to process, transmit out through mouth and hear through your ears, isn't it? So such an architecture, then the transmit and receiver are plugged into one architecture called as a transceiver. So it has a both transmit chain and a receive chain. Yeah. So this same antenna can be used for, let's say in this case, this is the receive chain and this is the transmit chain. So what the antenna receives goes in here, whatever the signal transmits goes in here, and the antenna radiates out. So the receive chain has the demodulator A to D and digital baseband, whereas the transmitter has the modulator, a digital to analog converter, so on and so forth, convert the digital baseband to analog. So the sensor inputs or whatever data that you want to transmit, all of them are in the digital baseband, but the communication happens in the analog world. So this is the digital world.